Let's go ahead and record. So I'm going to move over onto my recorded screen and you guys can follow along. So what we're going to do is we're on structural, we're on assignments, we're on Unit 2 floor framing. Now, before I get into this and we start to learn about how to size structural members, you're going to see that at the end of this, we end up with a very, very official looking thing with a printout, a report with all kinds of calculations and numbers. And this is very impressive. Now, the problem is, have you ever heard GIGO? Garbage in, garbage out. Okay, so if you don't really know what you're doing and you tried to do hand calculations and turn them in for a building permit, and it was like scribbled on the back of an envelope and numbers were crossed out and you couldn't read the writing, and then they came out and said this beam should be two 2x12s, nobody would believe it. They're like, this person doesn't know. I was going to say a bad word. They don't know anything, and they 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 would really look at it with a fine tooth comb. The problem is you can make absolutely incredibly stupid mistakes when you input the numbers on here, and it'll come out with the same professional looking report. So you need to keep your wits about you when you do this stuff. So like it asks you for tributary area for beams. And if our tributary area is 13 feet and we put in 1 foot, which is the default number, our beam is sized 1/13th, like 8% of what it should be, and it would fail. If a beam is sized only 8% of what it should be, it would fail. Now, the problem is you made a stupid mistake, but nobody knows it by looking at the report. They would have to have enough experience to know that, hey, they got the tributary area wrong on this. So you got to use this. I'm teaching you this because it's a great learning tool. It's a great thing for using like on your capstone project. You might say, hey, Pete, how thick should my floor be? How deep should my floor be? What should I've got this span. Can I, my client doesn't want columns in the basement. How far can I span this beam? So I can just say, hey, you know how to use Forte, figure it out on Forte. So it's a great tool for planning and all that. But if you're going to use it in the real world, if you've got a business like some of you do, and you're going to use this for sizing things, you got to be very, very careful using it and make sure you've double checked it and know what you're doing, because it's very easy to make a mistake that still looks professional. So let's go ahead now that I've yacked long enough. Hopefully you're all in Zoom and following along. We're going to go to assignment two, not assignment, we're going to go to Forte Web Weyerhaeuser Structural Website. And the one I just handed out to you is Forte Web Lesson and Exercise. So if you want to look at the electronic copy, that's where that one's located. I've got it already up on a tab here. So that's my script that I'm following along. This basement plan is the one we're going to use. So I've already got that pulled up here. So that's the one we're going to so this one was done with 2x10s. Now I didn't do this drawing. This was the first instructor that ever worked in Western Technical College. I just used one of his old drawings because it's a nice simple floor plan that's got some floor framing things going on. But this was so old that he's got the floor spanning with 2x10 joists. And then he's got a 3-ply 2x12 beam, which is like the real old school way of doing it. So we're going to use Weyerhaeuser and we're going to update this into using engineered lumber for both the beams and wood eye joists for the joists. Okay, so that's the drawing I'm going to be referring to when we do our example. So you need to go to this site and hopefully this link still works and get onto the Weyerhaeuser website. Now you're going to have to create an account. So I'm going to have to give you some time before I start here. And so hope the link works like this. So now you want to click on Access Forte Web Now. So this is an online software. You can use it any place you've got an internet connection, and it's free. So I'm going to click to Access Forte Web Now. So use your school email address, but you're gonna have to click on need to register. I'm just gonna go ahead and log in. Now, when you register, they ask you what company you should put Western Technical College. Um, they ask you for your phone number, and I I gave them my phone number, and that's how they contacted me. And I asked them, why do I have to give them the phone number? And he said that since this is professional level software, if we find a flaw in the software and it screwed up your calculations, we might need to call people and say, hey, you got to install this update right away because it's got a flaw in it, and it's so I don't care if you put your real number in. I put my real number in and I didn't get on a bad like a bunch of junk calls. They haven't spammed me. But I understand if you don't want to put your phone number in, maybe just make up a number. I shouldn't be recording this, but do whatever you feel comfortable, but you need to make an account to use this. So I'm going to go ahead and log in.
Just put Western for.
Yeah, at Western Technical College. Now, this video is actually pretty good for the short introduction, but I'll let you watch that on your own time. They've got a YouTube channel. Let me just click on this link. They've got a YouTube, they got ads on it. They got a YouTube channel. If you look under their thing there, they've got a lot of tutorial videos about how to use Forte Web. So if you want to get more into it or have somebody else explain it to it instead of me, you can go to the YouTube channel and watch videos on it. I'm just going to hit close here, and I'm going to give you some time to log in. Now, I think they might actually send you I'm trying to remember, they might actually send you an email to your school email address to confirm that the email is right. So you're going to need to do all that. And the reason they do all this, again, is because it's a professional level tool. And if they've screwed something up, they need to contact you and let you know that you're not like sizing all your houses with wrong software.
That'll come when they're.
So if you look at my script, once you first log in, they show you a user profile dialog. So that only pops up the first time you use it. And you can update your information or change your password, but I think the user profile page that will come up will look like this. So you can see I've got my name on there, my occupation, my company. I did put my real office phone number there, but you don't have an office phone number, so you can use your own judgment on what phone number to put in there. You can use mine, I suppose. Just don't do anything bad with the software. Then there's United States of America, City of La Crosse, Wisconsin. So that's how they knew that how to contact me when they wanted to find out like what we were using the software for and if they were interested in having them come talk to us about it. Okay, so I'm going to close that. And then once you all get logged in, we'll actually start learning how to use it. But I'm just going to kind of walk around looking backwards here and see who's logged in. Oh, sorry, sorry, thanks for not biting. Stepped on him. Sorry, I was walking past, are you okay? I'm really sorry. You looking at me like, what did you do? Stepped on this cloth.
Don't worry, you'll have a present later.
Yeah, all right. So I have to say that Yuma I was a paper boy and I got bad experiences with dogs, but Yuma has changed my mind about dogs. I'm a dog fan now, and it's all because of Yuma. Um, okay. So I think most of you are in, am I right? You just have to catch up as best you can. Maybe your partner can help you out. So what we're gonna do is I'm working on my list here. And so what we want to do is go to this thing here is the file manager tab. So if you're not seeing what I'm seeing on my screen, I think you click there and it takes you to where I am now. So what we want to do is we're on item 4 on my script. We want to hit new file. And I'm going to say, I'm going to call this 2026 floor example. And then I'm going to hit the blue check box. So now it gives you up on this left hand, it's given me a level. It's giving me the jobs settings. IBC stands for International Building Code. That's the one we want to keep it on, but we don't want to use the old code. So we're going to change the code to IBC 2024, which is the current code. The connector manufacturer, these are two big connector manufacturers, but really the 800-pound gorilla is Simpson Strong Tie. So they should be used as your connector manufacturer. The load duration factors can all stay as default. So the reason for the load duration factors are if you size a building for something that's there 24/7, 365, you have to size it like it's there for 24/7, 365. If you're sizing something for like a wind gust that only happens for like a split second, you'll have like 100-mile-an-hour wind gust, but it's not going to be blowing for like 24/7, 365. The way it impacts the structure can be adjusted, and that's what these load duration factors are. So you see the things that are there forever, like your gravity loads, those are a 1. You're not ever going to have a lesser duration. But the things that come and go and fast are like earthquakes and wind loads. So those have a higher duration factor. And the snow loads, they don't last forever. So they would be a little bit more duration factor. They're not as much as gravity because they're not there 24/7, 365. Okay, so now let's go ahead and look at the job. Yeah, go ahead.
So if you're in Wyoming designing a house and it's super windy all the time, you
Yeah.
get up that number. If you're in.
Well, the code might actually tell you different, but the reality is you're gonna have a wind load based on the code, but the fact that it's super windy all the time probably isn't going to impact your building because like a 20-mile-an-hour wind is more, it's not like the buildings are designed for a 20-mile-an-hour wind versus a 10-mile-an-hour wind. They're designed for like 80 miles an hour wind or 100 miles an hour winds if there's like a tornado or a thunderstorm. Does that make sense?
Like a seismic wave.
Yes, yeah.
Seismic area, then it.
I'm not enough of an expert about seismic, yeah. So I don't know if they look at your geography about where you're located and adjust it that way.
Is it based off of that zip code?
Yeah, it might be. I should have the guy here while we're teaching it, so because I don't know the answers to that. Yeah.
That actually. Something that's only in America.
It's actually international. No, I don't know what other countries use it, but you know, there is a conspiracy theory that we're going to have a one world government. And the fact is, they've been doing this code thing for decades now, and they want to have a one world code because these big corporations who basically run the world are fed up about having to do a different code in every country they build buildings in, right? So they want to have one code that covers the whole world. Now, I don't know how many countries have taken it over, but that's an excellent question. But it is truly international. Let's get our job notes done here. So I'm going to type in 2026 in class for forte floor lesson. And I'm going to put my name on it here. Design information provided by Pete Zerbel, and you can put your name on it. And then we have our zip code. And like Todd's saying, I think that zip code actually might adjust it based on seismic and wind loading, but I'd have to go back and check with my contact at the company to see if that's the case. So that's nothing we need to look at because that's just a job summary. If we had like the job all done and we wanted to print out the summary or print the materials list or print the design. The wind loading, I just leave this blank for now. I leave it at the default risk category residential one. But this is where we could adjust the wind speed based on the maps, like Todd was talking about. Same thing with seismic. This is where we could adjust the seismic category based on the code requirements. Okay, so let's just go back to job settings here. So everybody kind of caught up on, I've been talking a little bit more. And Bethany, this is being recorded, so if you do miss parts of it, you can just watch the recording when I post it. So now what we're going to do is look at the job tree, and we're going to hover over the level, and we're going to use the blue pencil, and we're going to call it first floor. Because, you know, we might have a house that's got more than one level. So rather than just leaving it as the generic level, and then I hit the blue check mark. So I'm now on the bottom of my first page. So if you look at our drawing here, we have floor joists that are spanning up and down on the page, and we have a beam that's running down the center. Now you'll notice on this drawing here, this designer hatched the wall and they didn't dash the footings. So just keep in mind that the dashed wall is our foundation wall. And so they have a 3-ply 2x12 beam. So we have to design the beam first, and this is why, because the floor joists bear on the beam. And if we go with a 2-ply beam, it's going to be skinnier than a 3-ply beam. And that how wide that beam is determines how much load is going on the end of that floor joist that's spanning over, right? If I have a wider beam, that load that's going down on the beam is being spread out over a wider area of the floor joist than if it's a really skinny beam. Does that make sense? Because they're like perpendicular to each other bearing. So we always design the beam first because that gives us our bearing for our floor joists. Okay. So that's what I was saying on item 9 on my first page. Now I'm going to switch over to the second page of my script here. So this example plan shows 3-ply 2x12 beam. So this is the old school way of doing it before they invented engineered lumber. So how wide would a 3-ply 2x12 beam be? If I took a tape measure and I measured over the top of that beam, it's a 3-ply 2x12. How wide would that be?
4.5.
Yeah. So a ply is just 3 stacked next to each other. So I have 1, 2, 3, and they're all 1.5 inches equal, right? 2x12s are 1.5 inches. So that's how Shane got 4.5. He took 1.5 times 3 equals 4.5. Nod your head if that makes sense. So I've got 3 pieces of wood standing up like that, nailed together. That's the old school way of doing it. So we are going to size it for drop floor beams using laminated veneer lumber. They're also called micro lams. So these are the ones that are made in a factory and they're 1 3/4 inches wide. So we're going to use a 2-ply beam, which is going to be 3.5 inches wide. We're going to try to minimize the depth. So when I say minimize the depth, that beam is hanging down from the floor. I'll just right over here. So our floor joists are going to be running across. I've got a dropped beam and it's going to be a 2-ply, 1 3/4. And when I say minimize depth, I don't want to hit my head on the beam as I'm walking around, right? So I'm going to try to minimize that depth. What else do I got on my script here? I'm going to use a L over 360 LL deflection and L over 240 total load deflection. So the LL stands for live load. So remember, that's how far it's going to sag down when it's fully loaded. So we're gonna keep the deflection at L over 360 for live load and L over 240 for total load. Okay, so now that I've explained what we're going to be doing, let's go ahead and actually add it on there. So let me get my tabs in order here. So when I click on this first floor, we just can keep it like that. So now what we're going to do is we're going to click the green plus and we're going to add our beam onto that first floor. And what I love about this software is it's like, it's got pictures. I don't even need to know how to read. All I need to do is like, what am I going to do here? I'm on a floor. So I've got ceilings, walls, posts, roofs that I can size, but I'm on floors because we're learning about floors. So I've got floor joists, I've got a dropped beam, and I got a flush beam. I already talked about the difference. They're just, this one's down below the floor and this one's in the level of the floor. So we're going to click on floor dropped beam. So let's call this worst case under member notes. We're going to call it worst case dropped floor beam. So deflection criteria, this is the code minimum, and that's what I showed you in my assignment or my script that we're going to use. We're just going to keep this at code minimum. Now, maybe in the final assignment, I'll make you change it from code minimum, but for now, we're going to keep it at code minimum. So code minimum is the minimum deflection that the code lets you have for this beam. If I was interested in a stiffer floor for maybe a high-end thing, I would probably pick high or I'm sorry, improved, or I'd pick a different number to get me less deflection in the beam. So we've got code minimum set up and we're not checking any of these boxes. Okay, so now we're on our floor thing, and now all I need to do is we just walk through the tabs from left to right. We've got the member notes typed in on the member info. Now we're going to click over onto spans and supports, and this is the critical one. And then loads is critical. Both these are critical. So you have to make sure you have the correct dimensions and material as well as any accessories. So I've got a little picture on my script here. So let me just show you my script. If you can't see this little picture, you have to click on the green picture eh, under Forte that shows a little diagram. So where it says show member graphic, you need to click on that. Okay. So this is just a default that it's put some numbers in there. It doesn't know anything about our project. So now I'm going to go back and look at my residential example here. So you can see we've got 11 foot 6 plus 6 inches to get to center on these beams. So this beam is center to center, that's 12 feet. This one's center to the edge of wall is 12 feet, and then it's 10 inches. And this one's center to the edge of wall is 12 feet, and then it's 10 inches. So since this is going to be a little bit longer span than the center span, we're going to pick this right span here, and we're going to make our diagram. So if you look at your script that we're working on, which is up here, we're going to make it look exactly like this picture. So it's 12 feet from the center of the column to the edge of the foundation wall. And then it's going into a 4-inch beam pocket on the masonry on the right side of the wall. Okay, so let's go ahead and looking at my script here on my piece of paper, I'm going to go in and type the things in here. So the first thing on span I'm going to click on is, am I going to do it clear span, out to out, or custom dimensions? Well, I'm going to do it custom dimensions. And I'm going to click on span 1 and I'm going to type in 12 and then enter, or click out of the box, and it makes it 12 feet. And now let's work on support 1. So I went on the Menards website and I looked up these column caps and I saw that they were 8 inches long. And so if the column caps are 8 inches long and I'm going to the center of that column, I'm bearing on 4 inches of steel. So on support 1 on bearing length, I'm going to change that to 4 and then hit click out of the box, and it assumes inches. The dimension location I'm going to do is to the left. It's on the bottom of the beam, so I'm keeping that at the bottom. The top, the type is going to be, it's a column cap. So I'm going to find where it says column cap. The material automatically changes to steel, but that's what it is. And then the accessory, I'm going to say none, because we're not going to put any blocking at our columns in this case. So let's go through that again. Support 1 is 4 inches left, bottom, column cap, steel, none. So that's going to the center line of that column. Now on the right side, it's going into a 4-inch pocket in the concrete foundation wall. So we're going to change support 2 to 4 inches as well. Now this one, we're actually going to do it to the left because it's going to the left, the inside of that foundation wall where that pocket is. It's bearing on the bottom. And this time we're going to, instead of stud wall, we're going to call it a pocket. And it's going into concrete. And the accessory is none. So I'm going to leave this up for a bit here. Hopefully you've all caught up with me as I switch my page over. So let's just double check just while I'm waiting to make sure everybody's caught up here. Let me just go back and show why we've got this 12 feet to the center to the edge and then 4 inches bearing in. So my overall length is 12 foot 4. So let's go ahead and look at my plan. So from the center of that column, 12 feet to the edge of the wall, and then it's bearing 4 inches into the concrete. So the overall length is 12 foot 4. So that's how I came up with that. So now let's go back in here. This is the critical one. This is the one where I was telling you students make massive mistakes and they can really get answers that are way, 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 way off if you screw this next one up. So now we're going to click on the next one over called loads. So uniform load, remember, means that it's every so often a joist comes onto it. I don't have a big column sitting on the beam in the middle of somewhere, so we keep that the same. It's over the full length of the beam. Check that box. That's all good. This is where students screw up. See, the default tributary width is 1 foot. And if we don't adjust that, it's going to assume that there's only 6 inches on each side of that beam bearing onto it, which we know is not the case. So this is where you can screw it up. So now we have to figure out the tributary load onto that beam. So you can see this dimension here is 26 feet. Do you remember the half and half rule? What's our tributary width that's going onto that beam? The floor joists are going up and down. If we take our half and half rule, how much of that tributary width is going onto that beam? 13 feet, right? Because if half of this span is going on there and half of that span is going on there. And it doesn't matter if the beams in the center are offset, it's always taking half because it's always taking half of each span. So we're going to put 13 feet in there. So where it says 1 foot, this is where students get beams that are totally undersized. We're going to change that to 13 feet. So that's probably the most critical thing on sizing a beam. Now, we've got a dropped beam, so that load is coming in from the top, so we need to change that from to the top. Now, now its default for dead load is set to 12, which will meet code. But when I was doing these custom houses, I always bumped it up to 15. And the reasoning is I didn't know if they were going to put heavy duty thick tile on there or just sheet vinyl. So I always bumped that up a little bit. So we're going to do like I did, and we're going to bump the dead load up to 15. Now, if this thing was a roof member, I need to know the roof slope because if I've got a really steep roof, it's got more shingles on it and more dead load than if the roof is really narrow for the same span. So I see Todd looking thoughtful here. I'll try to do a drawing to explain it. So if this was a roof member for whatever reason and it was sloping, and it's both going the same distance, right? This width is the same, say it's 13 feet here. There's a lot more shingles that go on that roof, and there's a lot more dead load that goes on that roof than there is on that roof. Okay, so that's why they ask for the roof slope if you're into designing roof members, but we can ignore that. We're just doing a floor. So our floor live load, based on their code is 40, which is good because Wisconsin's code is also 40. Now, Wisconsin does not use the International Building Code, as we're going to find out. We still have something called Uniform Dwelling Code. Wisconsin is very, very proud of their code because we were one of the first people that came up with their own codes. And the builders love the Wisconsin code because it doesn't require them to do a lot of the energy efficiency things that the International New World Order Code does. Okay, so the Wisconsin fights to keep their own code, but we're still at 40 pounds per square foot. So we're inside a house, so we don't have roof load, we don't have snow load, we don't have wind load, we don't deal with seismic here in Wisconsin. Okay, so we're ready to move on for that. Now, if we knew we were going to have big holes in our beam, we could put them in there on holes. So we don't have any holes, so we're going to ignore that. We're going to ignore what?
Stairs.
No, holes would be like I've got a big plumbing pipe that I can't move and I got to drill a hole in my beam. Okay. Um, the location analysis, this is just if you want to show shear and moment diagrams for the like your calculations. We're going to ignore that for now. You had your hand up. You have to click on the little green picture.
Oh.
Yeah. And then it'll show it there. Okay, so I'm in the middle of the script on item 21. So we're ignoring holes and location analysis. Now we're going to go into product selection. And so this lets it know, like, I can make this thing out of glue lamps. I can make it out of steel. I can make this beam out of just 2x12s again. But we're going to make it out of micro lam LVLs because that's typically what lumberyards stock. And that's what typically I see on job sites when when I go around and look. If people are doing engineered lumber beams, they don't use paralams because they're more expensive and they're not stocked. Now, Weyerhaeuser is trying to push timber strands. So even if we don't, timber strands are like beams made out of like OSB with all the chips everywhere. And I never used them because they were invented after I left the real world. So I've never used them, so I don't feel comfortable with them. Have you guys either used timber strand beams? You have for studs, but not beams. So they're trying to push this because they must make more profit on it because it's just a bunch of wood chips. So they're going to give us timber strand even though we're not asking for it because they're trying to push people to start using them. I mean, they're using their software to kind of get this product out in the market. So we're going to click on LVLs, micro lambs. We'll click here. They used to make different series of different strengths or different widths, but now they're all 1 3/4 inches wide. And this is the modulus of elasticity. And now we have to pick the depth we want. So we're going to shift click all these because we're going to try to minimize our depth.
If you click the little check mark by the depth, maybe it clicks so small.
Oh, okay. Good. So I learned something. But we're not going to, so if you click this little checkbox by depth, it selects all of them. But we want a 2-ply beam. Okay. So we don't want a wider beam because it's not necessary, but we don't want a real narrow beam because that limits the amount of load that each joist pushes onto it. So you typically use a 2-ply beam in most projects. So we're just going to click the one for 2-ply. Now we're going to go to solutions. And this one is absolutely critical. We only show solutions that pass design because we don't want to see the ones that have failed. See, so you can see the 5.5, 7 1/4, 9 1/4, 9.5, 2-plies all failed. So we want to just only show solutions that pass design. Now, did I check the box for the timber strands? No, I did not. But they're trying to show how, hey, look, these are cheaper. This is their cost index. These are cheaper and they will still do the job for you. They're a little bit deeper, but they'll do it for you. So they're using this as marketing, but I'm not going to fall for their marketing until somebody tells me that these are going to be good for the long term for beams. So I'm going to stay with micro lambs. So I was trying to minimize the depth. And so I'm going to pick the 11 1/4 one, which also luckily is the cheapest of all the micro lamps here. So I have to highlight that one because it does the report based on which one got highlighted here. So now we click on report. And you can see why this, when you turn this into your building inspector or whatever, this looks really professional. So it's got a little diagram. It shows the reaction, which is how many what's the amount of load that's going down into the bearing at each end. It's showing the amount of shear, the bending moment, the deflection in inches, and the total load deflection in inches. So it's the maximum, this is deflecting under maximum loading. So if it was taking 40 and 15, it would deflect 0.435 inches, 6 feet 2 inches in from one end. And then it gives you the actual and the allowed and how much of that allowed you're using. So you can see the reaction is only using 43% of what would be allowed, but the moment, which is the bending force, is using 80% of what is allowed. Okay, so when I grade this, I can look at this and I can see, oh, they're using the right bearing length at the end. So if we wanted to print this, we can go to the printer and save a PDF of it. Okay, where it says lower right corner, it says print report. We can go in and make a PDF. So when I ask you to turn in the PDF member report for the assignment that I'm going to give you, that's what that is. I haven't clicked these other two boxes here. I'm just going to click on it on mine and see what it shows you. Oh, so it gives you a shear diagram and a moment diagram and a deflection diagram. So that's pretty cool. Let's see what this one does. Full detail. Okay, so it's just more based on whether it's dead plus live load, what the various things are. So we can ignore those for now. For the assignment, we're just going to click on the printer. Okay. So now that we've got our beam done, now we're going to go ahead and design the floor joist. So I'm on item 26 on my script, so I'm going to go into the example here. So in the old days, you couldn't get a 2x10 that was 26 feet long, that wasn't all warped and twisted. Maybe you could, but it would cost like gold, right? So nobody's cutting these huge trees down where you can get perfectly straight 26-foot long 2x10s. But with engineered wood eye joists, we can get a 26-foot long one. They're not that hard to carry. Two people can set it up on the site. And we're going to just get one that goes continuous from wall over the beam to the wall. Okay. So we're going to assume that it's spanning 26 feet out to out and it's sitting on a 2x8 plate. Okay, so the plate is the part it's actually sitting on. It's not sitting on the 10-inch thick concrete wall. It sits on a wood plate. Sometimes they make them out of 2x6, sometimes 2x8. What do you guys typically see on the site? Yeah, if we're sitting on the plate on the wall, is that a 2x6 or a 2x8?
Depends on what size your foundation wall is.
Yeah. 2x6. I picked a 2x8 in this case, so we're going to do a 2x8. Okay, so that's where we're going to go. We're going to go 26 feet out to out. So what we need to do now is we're going to click on the plus again, and we're going to add a member here. And this time we're going to click on floor joist. And under my member notes, I'm going to write floor joist, comma, continuous over beam. And in this case, I'm going to keep it on the default in improved deflection. I'm not going to the code minimum in this case, because if you're going to get a bouncy floor, it's going to be your floor joists that are the bouncy one. It's not going to be the beam that gives you the bounciness that much. So I'm going to keep this at improved. We're going to use L over 480 live load deflection and L over 240 total load deflection. We're going to allow web stiffeners at intermediate supports. We're going to keep that on there. And we're going to allow repetitive member increase. We're just going to keep all this at the default. Okay. Now, we're going to, if you're looking at my item 626 on my script, let's go to item 26 here. As we get onto this here, since we were using 2x10s and we don't want to make the floor, 2 feet deep because now all our stairs are going to work. How big is a 2x10 up and down? 9.25. But we're going to allow ourselves to go 1/4 inch more. So we're going to limit the depth of our floor joist to 9.5 inches. And we're not going to let them be spaced closer together than 16 because that makes it hard to run your HVAC and all your piping between your joist space. And we're going to use a TGI Pro rating, which we'll talk about, of 40 for the joist. So that's where I'm getting all that stuff. Okay, so now we're going to click on to the spans and supports on Forte. And I'm on, if you go to my script at the top of the page. So we're going to set this thing up with a span, custom dimension locations. Our span 1 is going to be 12 foot from the outside to the center, and our right span is going to be 14. Now, I want to go ahead and look at to show you where I got that. So see from the center of the beam, 11 foot 2 plus 10 inches, that's 12 feet. And then if I add all these numbers up, it would be 14 because they got to equal to 26. So I'm going 12 foot on one way, 14 feet on the other. So that's where I got those two numbers from. So my span 1, I'm going to make 12 feet. Span 2, I'm going to make 14. My overall depth is going to be 26 once I get my things adjusted here. So I'm gonna work my way from the left to the right. So left is a foundation wall with a 2x8 plate on it. Right is a foundation wall with a 2x8 plate on it, and the center support is that beam we just sized. Okay, so our bearing wall, our bearing length, since I used a 2x8 plate that my joists are sitting on, is going to be 7.25 inches because that's what a 2x8 is. That dimension location is on the left side because it's to the outside of that plate. It's at the bottom. We're going to make it a plate on concrete. Spruce pine fir, that's fine because that's the lumber we use. And we always have a rim board on these projects. So we're going to use a 1.25 inch rim board on here. So that's that line where my mouse is going up and down on the screen. We're going to keep that in there. So now that we've got the foundation wall on one side, let's do support 3 where we just copy all that over. The only thing we have to change is that now we're measuring to the right. Bottom still stays the same. Plate on concrete, spruce pine fir, then we have our 1.25 inch rim board. Now, where students, when they do the assignment, get messed up is they don't remember that they have to set that middle support, which is where the beam is, to what we actually sized our beam as. So we have 2 plies of 1.75 inch micro lambs on our selected beam. So 2 times 1.75 is 3.5. So that's good. The dimension location, you can see now it's clear span. It's going to the edge of the beam. That dimension, if you looked on the plan, was to the center of the beam. So we're going to change that to center. This is at the bottom yet. We're going to change it to a beam. We're going to change our material to microlam LVL. Now, why is it important to tell the material? Because microlams can take a certain amount of force pressing down on them without mushing. A soft piece of wood, like if you imagine a piece of balsa wood, that could take hardly anything. Steel or, I'm sorry, like paralams might even take more than a microlam. So we need to tell the right material and the right width there. We're going to keep the accessories at none. We're going to keep this, we're not going to change anything on the bracing and the bracing intervals. Okay, so now we're going to switch on to the loads tab. And again, we need to change our dead load to 15. We're going to keep our floor live load at 40. Now, why don't we have a tributary width on this one? Because its tributary width is based on how far the joists are spaced on center, and it's going to tell us what the spacing is on the joists. It's not like a beam where that tributary width is depending on the house. The width on how much load's coming on depends on the spacing, how far the joists are spaced apart. So we don't need to, this is very simple. We just make sure our dead load stays at 15 and our floor live load's at 40. Okay, so now we're going to go to we're going to skip holes because we don't know now holes. We're going to skip location analysis. Now we're going to go to floor performance. So what TGI realized was their biggest concern was people not being satisfied with the bounciness of their floor or the stiffness of their floor when they walked on it. So they came up, they did tests and they interviewed people and they said, if we make this floor this stiff, 85% of people will find it excellent, while only 16% will find it marginal to unacceptable. So as you know, people are different. Some are super picky and other ones, they're just happy to have a roof over their head, right? So in this case, if it was 45, 84% would find it good to excellent, while 16% would find it marginal to unacceptable. Now, if I'm doing a house for habitat, that's probably okay, right? Because they're happy to have a roof over their head. If I'm doing a house for a really picky rich person that has attorneys on staff, I'm going to crank that sucker up because I don't want them to be the 1% that finds it unacceptable and then they get their attorneys after me. So this is what allows you to make that floor stiff or not. For in this case, we're going to keep it to 40. I might change it on the assignment. I don't remember if I did, but if I do change it, that's where you can type in that number there. So now we have to talk about what's the subfloor that's going on top, the part that you walk on. So we're going to use, this is typically called 3/4 inch OSB, but the actual, they keep shrinking it. It's not actually 3/4 anymore. Now it's 23/32 instead of 24/32. Um, Glued and nailed is good. We're gonna leave it as that. Now I would never do nailed only because nails are where you get squeaky floors. So you always do glued and nailed. Um, I actually went to the stage at one point in my life that I had glued and screwed because I thought screws were even better. But the reality is the glue is so good now that you don't need to dink around with doing the screws. Okay, so we talked about strapping type. That means like if we put a piece of 2x4 underneath the floor, we didn't have a ceiling, but we wanted to put a piece of 2x4 to stiffen it. We're not going to do that, and we're not going to show a ceiling. But your ceiling and the strapping, or if you put a 2x4 across, or if you actually put drywall on it, that would stiffen the floor up a little bit and make it less bouncy. But we're going to assume worst case, we're not going to put either of them on here. So we're not going to check any of those boxes on here. So now let's go to product selection. I'm on item 30 on my script here. So I'm going to use TJIs, which are those wood eye joists. I'm going to select all these series. Now remember from that other assignment, these are the skinny ones and the super beefy ones. So we're going to we're going to let them size it for all of them. I only want 9.5 because I don't want to have to mess with my stairs because I'm going from a 2x10, which is 9.25. So I'm only going to pick 9.5. And then I said I didn't want to go under 16 on center. So we're going to select everything except 12. Now, this is important. We don't typically double up two TGIs next to each other, like doublers. So we're just going to only pick one ply. We're just going to have one TGI, whatever series it is, at 16 or 19 or 24. And so now that we've got that all done, we're going to go to solutions. We're going to check the box that says show only solutions that pass design. So that limits it down. So as you can see, they're trying to sell me timber strands for my floor joists. And I'm just a little leery about them. No, I need to talk to somebody in the real world that's used them on like hundreds of houses and they're good, but they're something's well, the other problem is that you can see they're a lot more expensive than the TGIs are. So in this case, I don't know why they're even suggesting them. Okay, so we're gonna pick the lowest cost one that satisfies everything. So in this case, we're gonna go with the one at the top, 9.5 inch TGI 110s at 16 inches on center. So now we're gonna look at the report. And so you see it's got the diagram, all the same numbers we went over before. And so if I was going to do this as an assignment, I wanted to turn I'd go to lower right and I'd hit the PDF report. Okay, congratulations, you made it through the lesson. So I know I've been talking for an hour now, but if you just give me like 5 or 10 more minutes, I'll get you started on the assignment. You can take a break and then come back in and hammer on the assignment. Since it's still fresh in your head, I just want to go over the assignment because you're going to see how close the assignment is to what we just did here. Okay, so we're going to go to assignment 2.3 forte floor. So I actually showed you a picture of what we've just been talking about. So this is a dropped beam. This is a column cap. So and that first time when we measured the beam, when I measured 4 inches over from the center line, that's this distance from the center of that column over to the edge of that column cap. These are the TGI wood eye joists spanning continuously over the dropped beam in the center. Okay, so that's just to help you visualize it. So here's the drawing we're going to use. So let me pull up the drawing on my other thing. So it's Assignment 2.3 forte drawing. So floor joists are gonna span up and down on the page and they're continuous over the beam. You are going to size the worst case beam. So I made it very obvious which one's the worst case here. But there's your dropped beam line. That's your column. That's your footing. I've given you all the dimensions you need on this in order to do this assignment, okay? So now let's show you the assignment document. Let me pull that up on my other one here. Assignment 2.3 forte floor. Using Forte structural software, create a report for the dropped beam and floor joist for the attached plan. Assume a floor load of 40 PSF live load and 15 PSF dead load, exactly like the example. Use 2024 IBC code. Now, when you do this assignment, I want you to make it a new project and do a new beam, and I don't want you to edit this one or try to add it onto this one that we just did for the example. You should make me a new assignment called assignment number 2.3 floor in Forte. So you're going to size the worst case beam span, and as I said before, this one is obvious, which is the worst case. The beam's going to be bearing on a steel column cap 8 inches long. So the bearing length on each end will be 4 inches with a 16-foot dimension out to out. Well, I'm just reading that now. I just basically told you what the worst case scenario is. You don't even have to think about it. So there's no blocking accessory at supports. The beam width should be 3.5 inches minimum and 5.5 inches maximum. So why did I pick 5.5 inches maximum? 3.5 minimum I can understand because I'm using 1 3/4 inch LBLs. 2 of them is 3.5. 5.5 inch maximum is just based on if I have a 2x6 stud wall and I want to run it up and have it underneath the beam, I don't want it ever wider than 5.5 inches. Does that mean I can use a 3-ply beam? What's 3 times 1 3/4? Anybody do the math in your head? 5.25. So I can use a 3-ply beam and still do this assignment. So I can either use a 2 or a 3-ply beam. You must use microlam LVLs. So this is important here. Pick the solution with the least depth to get the most headroom in the basement. So I'm going to give you a hint since you've all been so, is it logical that I'm going to get a least depth beam at 3-ply or with 2-ply? Least depth. If I make it wider and put more beef there, is that depth going to probably come down to carry the load? Yeah, it probably will. So my guess is you're going to end up with a 3-ply beam here because I want to get the most headroom in the basement. So there's the L/360 live load and L/240 load, total load deflection. So you're going to size your beam first. You get 5 points for doing that. Then you use TGI floor joists. Use L/480 and L/240 total load deflection. They're continuous over the beam, just like our example. I'm using a 7.25 inch bearing plate on the foundation wall. I give you another hint that the beam must be sized first. We're going to use the rim board just like on the example. This, we're changing from the example. We're making the TGI Pro rating at 45 instead of 40. We're still going to use the decking material glued, nailed. We're not going to use the modifiers under the decking. The spacing should be a minimum of 16 inches, just like the example. And I don't want the depth of my floor to be deeper than 16 inches. Okay, so that depth can't be more than 16 inches. The joist should not be doubled. When you use wood eye joists, you don't typically double them together. So you pick the acceptable solution that meets all of the above. So it satisfies all these requirements and then minimizes the cost index. Create a PDF like I showed you of both of them, the beam member report and the floor joist member report. I want to upload those 2 PDFs to Blackboard. And then when you're typing in the project name, you should call it structural assignment 2.3 and then your name and the date. Okay, this is due start of class Thursday. So I'm gonna give you the whole rest of the class to work on it. Most students get it done before they walk out the door today. Any questions? Okay, go ahead and take a break. You've been sitting for over an hour. Then you can hammer on this, and I'll be here if you have any questions.